Hello everyone. Today we are working on a question from equilibrium. It's a simple question. Let's read the question first. A string S, I think you can see the question here. A string S is connected to the center of gravity of a rod R, and the other end is connected to a ball. As shown in the figure, one end of the rod is in contact with the ball, and it is in equilibrium. The coefficient of friction between the ball and the rod is 1 over root 3. Find the minimum value theta for the equilibrium. Right. Try the question first, and then later let's find the solution. It's an easy question. Try your
The
best.
question now. So this question actually we have to find the theta value over here. For finding the theta value, actually we need to consider the equilibrium of forces. So equilibrium of forces, I hope you know the basic principle is downward forces. All the forces, the resultant value, it has to be zero. Resultant forces has to be zero. And the torque, the moments has to be zero. So clockwise, anti-clockwise momentum has to be equal to clockwise momentum. So the system is in equilibrium, right? So here the basic forces we have here is this tension. You can see that this tension and the weight downwards and the frictional force. The frictional force that is acting upwards here F. So F equals mu r, right? So let's look at the equations we need here. Of course, we wrote frictional force F equals mu r, and torque for the moments is force into perpendicular displacement F into d, and for the equilibrium tau or the moments it has to be zero, right? So let's write the equations. The forces we need: frictional force mu F, let's say F mu, frictional force, and tension W, right? So if you are to use moments to take the answer, we can take moments from 2 points. From this point, let's say it's point A, and from this point B, right? If we apply the torques or the moment from point B, actually we need to find tension. So if you had to avoid finding tension, then we can use point A. So I'm going to plan to find the moment from this point, point A. So we don't need to consider tension here because we don't need to find tension. We only need to relate this theta value to friction, and then we can find the theta value. So let's apply our equations to point A. Let's take the moment from point A. So we don't need to consider this tension because we know tension acts on the same point, so we don't have to consider this tension here because it's not perpendicular to this point, right? And of course W we don't need to consider, it's also the same point, so we don't need to consider W as well. So the other forces in equilibrium is this, the reaction force. This reaction force gives a moment in anti-clockwise direction, and this friction gives in clockwise direction. So we need to consider these two only, right? Let's write our equation. Right. Initially, the frictional force F, yes, and on point A. So you can see the perpendicular distance. Let's say the distance is L to the center point L, and if the angle is theta, yes, the friction acts along this. So we need to consider this distance F into T. So since this is L and theta, L sine theta, so frictional force F into L sine theta, we get torque from friction. And then again opposite direction R, yes, into this length or this length L cos theta. So reaction force into L cos theta. So let's apply our values. Frictional force F equals mu R L sine theta equals R L cos theta. Right. Now you can see R and L we can actually cancel off, and mu, let's apply the value. Mu is 1 over root 3. R L cancel off. So sine theta equals cos theta, right? So they're asking us to find theta value. Let's find tan theta value. So we can easily find, yes, theta value. So sine theta divided by, we can bring cos theta over here. Sine theta divided and mu over here, cos theta over here. So sine theta divided by cos theta, we get tan theta, and mu over here, root 3. Of course, you know tan theta equals root 3. So theta equals 60. This is our answer.